Chapter 10 is on sinusoidal steady state analysis, and really what we're going to do for these videos is just a bunch of examples. You can look in your book and see more examples. Because it's all stuff you've done before, we're just now doing it with phasors. So here's the basic steps for everything in Chapter 10. You want to first transform everything to phasors if you haven't already been given the problem in phasors. You can see both of these problems, they've already done that work for us. Everything's in phasor notation, but it may not be. Step 2 is just solve using DC methods. Anything you want, anything you're already used to, what we've done before. Nodal, mesh, Thevenin, superposition, all of it still applies. Step 3 is transform it into the time domain if you're asked to. So for this one, you see it says find capital I. That means it wants it in phasor notation. If it said give me I of t, then it wants it in the time domain. So just pay attention to what they're asking you. So let's just dive into a couple examples. This first one is from section 10.2. It's on nodal analysis. So we want to write nodal for this circuit. So remember, first step of nodal, label the non-reference nodes, V1, V2. Now we want to write our nodal equations. I have V1 minus 20 at an angle of minus 90 degrees over 2. So at V1, we've got V1 minus 20 angle minus 90 degrees over 2 plus V1 minus 0 over minus J2 plus V1 minus V2 over J1, and then this leaving one here, so plus 5 at an angle of 0 degrees. Get rid of this little I of t now that's in my way. And just like our nodal equations we're used to writing, we set all of that equal to 0. So obviously now just the next steps are a little bit harder because solving these is not super fun. We can go ahead and combine everything we have for V1 and V2. So V1, I have 1 over 2. And a 1 over minus J2, and a 1 over J1. And I want to write that plus V2, everything I have for V2, well, it's just this one term, minus 1 over J1, equal to anything that's not associated with V1 or V2. So I have this negative, move it to the other side, it becomes a positive. So I have 20 at an angle of 90 degrees, sorry, negative 90, right, over 2. And move this term over, 5 angle 0 degrees. So I have that. And again, I can put this in my calculator as it is, or I can do the fun math on it, which you can look at in your book. All right, let's look at V2. What do we have? V2 over 4 plus V2 minus V1 over J1. I have 2i entering, minus 2i, and I have 5 angle of 0 degrees entering. So I have this I in here. I need to find my I. It's right here. I is equal to V1 over J over 2. So I can replace my I with V1 over minus J2. There we go. So all my V1s, I have a term here, minus 1 over J1. I have a term here, minus 2 over minus J2. Right, because there's a negative here and a negative here. Plus my V2s, 1 over 4, plus 1 over J1. That's all of those. Equal, move that to the other side, 5 angle of 0 degrees. All right, so if I solve these, I get V2, that's 20, angle 0 degrees volts, and a V1 That's 15.81 at an angle of minus 71.56 degrees volts. We were asked to find that I, right, this I right here. Come over here, I is V1 over minus J2. I have V1, plug that in, and I don't know. I didn't even bother to write it down. You get some happy face, some sort of number with hair and ears. There you go. Okay, so let's take a look at mesh. Again, everything works the same. We're just in a different domain. So mesh, they've already labeled I1 and I2 for us. So let's just start working our way. We'll call the first one mesh I1. We'll go around the loop. We have minus 40 at an angle of 30 plus J10 I1 plus minus J20 times I1 minus I2 equals 0. Combine my like terms. I have a J10 and a minus J20. I have minus J10 I1. This is my only I2 term, plus J20 I2 equals 40 angle 30 degrees. So there's my first equation. At mesh I2, I have minus J20 times I2 minus I1 plus 40 I2 plus 50 angle of 0 degrees equals 0. Combine my like terms again. Plus J20 I1 minus J20 and a 40. So 40 minus J20 I2 equal minus 50 angle of 0 degrees. So here are my two equations. Again, solve those any method you want. You can use your calculator, you can use Kramer's rule. If you did that, you'd have minus J10 and J20, J20 and 40 minus J20, I1, I2 equal 40 angle 30 minus 50 angle 0. Kramer's is in the back of the book in one of the appendix, so we need to take a look at that. Go ahead. But we get I1 equals 4.698 at an angle of 95.24 degrees amps, and I2 0.9929 at an angle 37.70 degrees amps. So that will wrap up 10.2 and 10.3.